Let's work through this circle problem carefully. We are given two chords intersecting inside a circle at point M. Along the horizontal chord, we have points X, M, and Y. And along the vertical chord, we have points U, M, and V. We know that MY equals 8 units, MV equals 6 units, and UM equals 18 units. Our goal is to find the radius of the circle. The first thing we should notice is that two chords are intersecting inside the circle, so we can apply the Intersecting Chords Theorem. This theorem tells us that the product of the two segments of one chord equals the product of the two segments of the other chord. In other words, XM multiplied by MY equals UM multiplied by MV. Now, let's substitute the values we know. XM multiplied by 8 equals 18 multiplied by 6. 18 multiplied by 6 gives us 108. So we have XM multiplied by 8 equals 108. To isolate XM, divide both sides by 8. This gives XM equals 108 divided by 8, which is 13.5. So now we know that XM equals 13.5 units. Next, let's find the entire horizontal chord X. Since XY is made up of XM and MY, we simply add them together. XY equals 13.5 plus 8, which gives 21.5 units. Now let's use an important property of circles. A radius drawn perpendicular to a chord bisects that chord. This means the perpendicular from the center to chord XY cuts it into two equal halves. Therefore, XK equals KY. Since the entire chord XY is 21.5 units long, each half is 21.5 divided by 2, which equals 10.75. So KY equals 10.75 units. Now pay attention to what happens here. Point M is already 8 units away from Y along the chord, and KY is 10.75. Therefore, KM equals KY minus MY. Substituting the values, KM equals 10.75 minus 8, which equals 2.75 units. Great. Now let's move to the vertical chord. The full length of chord UV is simply UM plus MV. That is 18 plus 6, giving 24 units. Again, the radius drawn perpendicular to a chord bisects the chord, so UL equals LV. Each half of the 24-unit chord is 24 divided by 2, which equals 12. Therefore, LV equals 12 units. Since MV equals 6 units, we can find LM by subtracting. LM equals 12 minus 6, which gives 6 units. Notice there's something very useful here. The distance from the center of the circle to the horizontal chord is the same as LM, so OK equals 6 units. Now we are ready for the final step. We can form a right triangle using OK, KY, and the radius OY. The side OK equals 6, the side KY equals 10.75, and OY is the radius that we want to find. Since this is a right triangle, we can apply the Pythagorean Theorem, which states that the hypotenuse squared equals the sum of the squares of the other two sides. Therefore, radius squared equals 6 squared plus 10.75 squared. 6 squared is 36, and 10.75 squared is 115.5625. Adding these together gives 151.5625. Taking the square root of both sides, we get the radius equals the square root of 151.5625, which is approximately 12.31 units. So the radius of the circle is approximately 12.31 units. That's our final answer. If this explanation helped you understand intersecting chords, chord bisection, and the Pythagorean theorem all working together in one problem, make sure to like the video, subscribe to the channel, and leave a comment telling me what type of geometry problem you'd like to see next.